What is this?
I enclosed.
I enclosed. Very good. Name of this law? What is the name of this
Circuital
law? Sorry?
law. Ampere circuital law.
Ampere circuital law or Ampere's law. Absolutely correct. In point form, we just discussed. In point form,
Curl of H equals to J.
absolutely. Curl of H equal to J. So these are the four equations, for electrostatic fields and steady magnetic fields. Notice that they are totally different, unconnected. The E equations and the B equations or H equations, they are not connected. They have nothing in common. Okay. However, when we study electromagnetic fields, then we will see that they can be connected in waves. So, as promised, the last topic of the day. Previously, we were talking of right. We had a scalar for electric potential, and we were saying that right. Is it correct or not? Is it okay?
Yes, sir.
Right. Just say phi E. What do you think? What do you think? Yes or no? Can we say this? Is it possible or not? What do you think? Can we do this or not?
So for electric field, when we are computing the electric potential, then we are bringing one unit charge from infinite to that field. But into
Yes.
the magnetic field, how we can bring, I mean, one unit magnetic like this, when we know the magnetic
We
monopoly
can bring a current element. You remember the force F equal to I N cross B. F equal to QE or even that F, that is Q B cross B. Remember? Only thing is that
Yes, sir.
charge has to move in order to, and the direction of V and B should be perpendicular, and there will be some force. So if your charge is at rest, then there is no force. Then we don't need magnetic moments. Can we say this or not? And how to define phi is current comes later. Is it possible to that some phi H may exist or not? That's the first question. If it exists, then we will bother how to define it or how to not define it. That comes much later. Can we say that does any phi H exist which makes this equation satisfied? They satisfy this equation? That's the question, first question. If it doesn't exist, then why we bother? If it exists, then we can try finding it. What will it exist or not? That's the question. Let us take curl of both sides. What is this? What is this? Can't hear you. What is this curl of H?
J.
J.
J. Now, what is curl of grad of phi H?
So 0.
So, so what is the conclusion? What is the conclusion?
J vector equal to 0.
Will J be always 0? Like the question problem which we solved just now. J was not always 0. Then the conclusion is that we can say this only for the cases where J is 0. If J is not 0, then this equation is not valid. Agreed?
So,
If the current density is not 0, we cannot write. We come to a contradiction. We cannot say this is this. Then what is the better alternative? If you want to have a potential, so this cannot be used. What else we can do? Second option is what about this? ये चलेगा? What about this? Will it work? Will it work? Anyone? See the equation carefully and tell. Can we write magnetic field as a divergence of another vector? Yes or no? What do you think? What is this? What is this? You just told. Can you hear me? Can you hear me?
Yes, sir.
Yes. What is divergence of E? Just now you told
Rho v by epsilon naught.
rho by epsilon naught. Rho v by epsilon naught. Is the vector or scalar? This is a vector or a scalar? Rho v by epsilon naught?
Scalar.
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 So is divergence of vector is a scalar or vector?
Yes.
Scalar. So this equation is
Scalar.
totally wrong. Divergence of a vector is always a scalar, so we cannot say it is divergence of anything. Doubt. Third option. This is now a scalar. Now sounds better. Sounds better.
Yes, sir.
Yes, sir.
But what is that divergence of H? What is divergence of H? What is divergence of B? Just now we have written
0.
0. So what is divergence of H?
Also 0.
Also 0. So ये भी नहीं चलेगा. Wow. Final option. What is the last option we have? There are 3 options. 2 are outright wrong, and the divergence of phi is equal to grad of phi is H. We can apply sometimes, not every time. And the other 2 are just wrong. So what is the last option we have? Last resort is this. This is always we define as B. Okay, it's not H. So let me write it this way. So this is the curl of a vector. This vector is called magnetic vector potential. Is it okay? Now see, so curl of A is equal to B, or 1 by mu, not curl of A is equal to H. Now, if we apply again, this is J. So, this must hold. This must hold. Is it correct or not? Is it okay or not? Or
Yes, sir.
curl of A is equal to mu naught J. Now, what is curl of a vector? We discussed in the very first class. What is curl of A? Is it 0 or something else? Is it curl of a vector is 0 or something else?
No, sir.
Hmm? Curl of a vector is 0. Sure.
So not 0.
Not 0. Then what?
The divergence into divergence of a vector minus.
The gradient of divergence of A minus Laplacian operator into A.
Yes, right?
Yes, sir. Yes, sir.
Yes. We define curl of A, but we didn't define this divergence. Okay, divergence of A we will discuss when we discuss antennas. Very interesting. How can we use divergence to our advantage? When we discuss antennas, we will see what is divergence. Okay, that's very interesting. But I will, for the time being, I am keeping this suspense. And what is divergence of A? We will discuss later. This is safe for antenna analysis. Okay. So for the time being, take that curl of A is B, or curl of A is B times. Okay. Finally, note one equation which we will not derive, but this will be useful when we study antennas. Not just useful, very, very important. And the equation is this we will use a lot when we discuss antennas. Okay, any questions? No more? Please solve problems. Write down a homework which you do not have to submit. Using Ampere's law, Ampere's arbitrary law, find H inside E and infinitely long solenoid B toroid of radius R. This I am sure you have studied in your school. Any questions? Thank you very much. Any questions? Any questions? Okay, then thank you very much, and we'll meet again on Monday. And yes, I forgot to say, on Monday we will start electromagnetics, the time varying fields. Okay, we start with Faraday's law. And second thing is that whatever we have studied so far, only in theory classes. So whatever we studied in lab class, transmission line, they are not included. Whatever we have studied so far is your MTS syllabus.
Sir, hello.
Yes, hello.
Sir, am I audible?
Yes, you are clearly
Sir,
audible.
actually, a computer application sir has informed that he'll be taking class from Monday onwards. So I think the class timing may clash as we are having class of computer application from 4:50 on.
How come it can be? You tell that I am taking class of 4:50. You can take class before also.
Sorry, sir.
You tell him that 5 p.m. I take the classes. So he can take the class before also. You ask him if it is possible for him or not. If it is not possible,
In the schedule,
in the schedule,
it is like we are having class from 11:40 and he's having